Hello, my people. Okay, last video on our review for the application of integrals. And as promised, this one is going to be volumes of solids of revolution. But what I've done is I've taken a region bounded by two functions, and I've asked my former students to take the region and revolve it around three different axes. Okay. And that's kind of nice because you already know the functions involved. You already know the points of intersection. It winds up being just about how to assess the radii expressions, and of course then how to set up those integrals as you move forward. Now, let's go ahead and take a look at those functions. Now, the first one is going to be revolving it simply around the x-axis. Let me get rid of this down here. Okay, it's going to be revolving it around the x-axis. Okay, now in order to find the points of intersection, that's actually not all that difficult. You would simply need to set those equal to each other, right? And if you have negative x squared plus 4x is equal to x, let's pull them over to the right-hand side. You're going to have x squared minus 3x. Oh gosh, look at that. Isn't that all nice and tidy? And I'm going to get points of intersection that are 0 and 3, which is kind of what you can read off the graph. So those points of intersection at 0 and 3 are going to give us our limits of integration. Now, when you're dealing with this one, when you have a region that is not flush against the axis of revolution, you're of course going to be dealing with washers, and you have to identify your big radius and your small radius. Now, the big radius is going to be determined by the one that is farthest away from the axis of revolution and is going to create the outside of that solid of revolution. And that, in this case, is going to be that quadratic right there, okay? And therefore, my big R, and I've taken basically it in vertex form and I've multiplied it out, is going to be negative x squared plus 4x. And therefore, my big R squared is just going to be that squared, okay? And so this becomes negative x squared plus 4x squared. Now, my small r is going to be just the identity function, so x. And so my small r squared is going to be x squared. So when I set this up, I know that I have to do pi, and my limits of integration are 0 to 3. And then I simply need my big R, negative x squared plus 4x squared minus x squared dx. Now, I'm not going to evaluate these just yet, okay? What I want to do is I want to show you the difference between this one and the next one, okay? And we'll come back and we may evaluate them. But let's go ahead and look at this. Now, I've done it. I've basically taken the axis of revolution and I've made it yellow so that it's really easy to see. Now, that is the same quadratic. It is the same identity function, but now we're going to be revolving it around this axis. Now, notice that the one that is farthest away from the axis of revolution is the constant function. But I can't just call it x because the radius has to do with how far away from the axis of revolution it is. Now, I know this is going to be really, really shocking, but you need to remember that distance is difference. Okay? Distance is difference. So if I asked you how far is 2 away from 4, you would kind of go, duh, it's 2 units away from 4. And I say, well, how do you do that? Well, you say, well, you just subtract. 4 minus 2 gives you 2. Okay, well, if the distance between 4 and 2 is arrived at by taking the difference, then surely the distance between 4 and this function can be done the same way, right? So basically every point on here is, is the ordered pair XX, okay? And the distance between here and the axis is x. The distance between here and this axis of revolution, y is equal to 4, is 4 minus x. Okay? So your big R in this case is 4 minus x. Your small r is going to be the same principle. It's going to be how far is this curve away from y is equal to 4? Well, we just subtract. And that's it. Okay? Now, this can be simplified. 4 plus x squared minus 4x. Oh my gosh, that winds up being x squared minus 4x plus 4, which is x minus 2 squared. And that makes it all nice and tidy because small r squared then is x minus 2 squared, which is x minus 2 to the 4th. Now, big R squared, remember when you square a difference, you can flip it around if you want because it's numerically the same. That means that if I'm looking for the axis of the volume of the volume of the solid of revolution, sorry, stumbling over my words, this is my big R squared, this is my small r squared. It's still the same limits of integration because it's still the same region, right? Still the same limits, still the same pi out in front. You're just spinning it around something different, so you've redefined your big R squared and your small r squared. And what you have here is x minus 4 squared minus x minus 2 to the 4th dx. Okay, well, let's do it one more time. The question, as I put on that old test, basically asked me to take that same region and revolve it around the y is equal to negative 2 line. Okay, well, again, it's not like you can't just use the function expressions for your big R and your small r. And actually, on the original one, you were functionally doing subtraction. You were just subtracting the function expression. You were subtracting 0 from the function expression because when you're doing it around the x-axis, it's the y is equal to 0 line. And so from here, though, it's the y is equal to negative 2 line. Now, again, just like the first one, and unlike the second one, it's the parabola that is now the farthest away from the axis of revolution, and will therefore not be my big R, but will certainly contribute to it. And what I need is my big R is going to be, well, how far is that distance? Well, we just find the difference, okay? And you can actually do it either way because, of course, you're going to be squaring it. And when you square it, whether it basically any sort of negative will get unnegativized, right? So let's just do negative x squared plus 4x minus a negative 2. Okay, well that simplifies to negative x squared plus 4x plus 2, and therefore my big R squared is going to be negative x squared plus 4x plus 2 squared. My small r is going to be x minus a negative 2, or x plus 2 when you simplify it, right? Because what is the distance between y is equal to x and y is equal to negative 2? Well, it would be the difference between those two functions. And my small r squared is going to be x plus 2 squared. Okay, well, same setup, same region, same limits of integration, same pi out in front. So pi integral from 0 to 3 of my big R minus my small r squared. Okay. And so what we've done here is we've simply altered. It's still the same. It's the same idea. I mean, and the thing is that we could take we could basically create any axis, any horizontal axis of revolution, and you would simply have to determine, okay, for this region, which function or which graph is farthest away. Well, that minus the numerical value of that axis is going to be my big R. And so basically anytime, so you could do this for just some nondescript, okay? You could say that region, okay, that region revolved around some y is equal to c line. And basically, here, I'll go ahead and put the functions back up here. It's revolved around some y is equal to c, as long as it doesn't cut through the region, which makes things a little more complicated, and we're not going to do problems like that. If it doesn't cut through the region, if it is either above or below the region, then you simply have to determine which value, like which one it is. So basically one of your radii is going to be negative x minus 2 squared plus 4 minus c, and the other radius is just going to be x minus c. Then you just have to determine which one is your big R and which one is your small r. And of course, how what those radii are determines, like, it has a huge impact on the volume. And if we want to see the volume, all you have to do is plot those integrals that that we basically derived into your calculator and press enter. Okay, which I will not waste your time with right now. I hope that that sort of solidifies a little bit in terms of why we go about doing the solids of revolution the way that we do. Again, if you have any questions, do shoot me a message on Teams or shoot me an email. Bye.